Okay, so we're on 4.1. We're talking about a triangle. And a triangle is formed of 3 segments connected together. Those points cannot be on the same line, so they're non-collinear. And those points are called vertices where they connect. And the symbol for a triangle is, of course, a triangle. Okay? Symbol for a triangle is a triangle. And if I gave you a picture, and I said this is A, B, C. All right, if I wanted to name the vertex of the triangles, how many vertex are there? 3. There are 3 points. The vertexes Y are A, B, and C. Separated by commas, they're capital letters. You name them like a point. Vertices is the plural for a vertex. And remember, adjacent means right next to, so adjacent sides. Side AB is adjacent to BC, right? And AB is adjacent also to AC. They have a common vertex. Either they shared the point A or they shared the point B. All right, legs of a right triangle. If you're given a right triangle, of course it has a 90-degree angle, and the legs are the 2 sides touching the 90-degree angle. So the legs touch the 90-degree angle. The hypothesis is directly across, the hypotenuse is directly across the 90-degree angle. It's the longest side of a right triangle. Not always, but if it's an isosceles triangle, okay, and it doesn't have to be a right, but the 2 sides are congruent. Now, it can be a right triangle, but it doesn't have to be. An isosceles triangle has 2 sides that are congruent. Okay, so isosceles has 2 sides that are equal or congruent. And if you're talking about a base of an isosceles triangle, okay, so if you have an isosceles triangle, and I'm drawing it different than I did before, but 2 sides are equal, let me draw that a little bit better. 2 sides are equal. Those are called the legs of an isosceles triangle. All right, not always. Remember, legs within a right triangle are touching the 90-degree angle. But the legs in the isosceles triangle are just the ones that are the same. The one that's not the same is called your base. All right. When that occurs, the base angles are always going to be the same also. So if it's an isosceles triangle, not only are your 2 legs of the isosceles triangle the same, but the base angles are the same. So if this one's 30, then the other one across from it has to also be 30. Okay? And the interior angles of the triangle, they're going to add up to be 180 degrees. Okay? They're going to add up to equal 180 degrees, all 3 of them. So if this one's 30 and this one's 30, then you have 180 minus 60 to find the vertex angle. And lots of definitions in this first part. All right, so you can classify triangles by several ways. First one, we can classify it by sides. If you classify it by sides, you can do an equilateral triangle, which means all 3 sides are the same. measurement. Okay. All the sides are congruent. It's called an equilateral triangle, and all three sides are the same measurement. That also means that all three angles are going to be the same, but that's dealing with angles. An isosceles triangle we just talked about. The isosceles triangle has two sides that are congruent. And the key word here, it says it's at least two. So realize that an equilateral triangle is also an isosceles. But if you can be more specific when you're giving an answer, you want to do that. But an isosceles has two sides that are equal. And a scalene triangle, scalene means none of the sides are the same. Okay, none of them have the same measurement. That's just an example of one. None of the sides are the same measurement. So on the test, I'm going to ask you to classify it by sides. You'll tell me if it's equilateral, isosceles, or scalene. Then I'm going to ask you to tell me, classify it by its angles. Well, acute means that all the angles are less than what? All the angles are less than 90, right? Equal angular means all of the angles are the same. And in this case, anytime it's equal angular, it's always going to be 60 degrees. Right? All those angles have to be the same, and they're always going to be 60. And yes, it is acute, but if you can be more specific when you're naming it, you have to. Okay? Even though all of them are 60, it's an acute triangle, but we can be more specific by calling it equal angular. If it has a right angle in it, okay, when you're naming it by its angle, you can call it a right triangle. And if you have a triangle where it has one angle that's greater than 90, then you can call it an obtuse. And just a reminder, all equilateral triangles are isosceles triangles, and all equilateral triangles are equal angular triangles, and vice versa. So be specific when you name it, because sometimes they can fall into two categories, but if it's more specific to one, that's the one you want to choose. All right, some types of isosceles triangles. We talked about this briefly a while ago, but here's a nice picture. If it's an isosceles triangle, of course, your legs are the same measurement. I told you that the base angles are going to be the same measurement. Okay. The vertex angle is the angle connecting the two legs. And of course, the base is the side that's not congruent. Not necessarily the one it's laying on, but the one that is not equal to the others. It's just a nice little picture to talk about. Base angles will be the same. Vertex angle is going to be different. So in example 1, I want to classify the triangle. I want to be specific as possible. And we're talking about triangle ABC has two acute angles and one right angle and two congruent sides. What kind of triangle would you name this? Okay, so let's name it by its angle. What kind of angle would you name it? Okay, it is a right. And then we can be more specific. What about its sides? What kind of sides does it have? Are any of the sides the same? You know, those little red marks are congruent marks, so that means it's the same. So which one has two? Isosceles. So it's a right isosceles triangle. On the test, I may be more specific. How would you name it by its angle? How would you name it by its sides? So you may write it as right triangle or isosceles triangle. All right. The triangle sum theorem, you add up all the angles, you're going to get 180 degrees. So if I gave you just a picture, whatever those are, the measure of angle A plus the measure of angle B plus the measure of angle C, it's always going to equal 180 degrees on any type of triangle. Okay, a nice thing to know, and these are a lot of times on your ACT, if you have a triangle with one of the sides extended out, okay, that angle 1 is going to be equal to the other two angles. Measure of angle A plus the measure of angle B. And if you think about it, 180 minus this angle, right, gives you angle 1. Well, 180 plus all three of these angles, or 180 equals all three of those angles added together. So that's where it comes from. But angle 1, or angle A plus angle B, if you add those together, you can get the exterior angle of angle C. The last part says this, two acute angles in a right triangle are complementary. So it means this. If you have a right triangle, then that means that you can add the measure of angle A plus the measure of angle C, and it will always equal 90 degrees. Always, in a right triangle. The other two angles that are not the 90-degree angle will always add up to be 90 degrees. Just saves you some time when you're doing problems quickly. All right, so example 2, you can apply the exterior angle theorem, which is saying I can add the two angles in the inside to get the opposite exterior angle. To find the measure, you want to first write out the problem. So x plus 50 equals 2 times the quantity x plus 4. And I just distribute. Remember, the 2 gets multiplied by the x, and the 2 gets multiplied by the 4. And then I get the x's on the same side, so I subtract x from both sides. I get 50 equals x plus 8. I get x completely by itself, so I subtract 8 from both sides. 42 equals x. Just be careful, all that wanted you to do was find x. If I want to find the exterior angle, I just replace it into the formula. 2 times the quantity, 42 plus 4. And 42 plus 4 is 46 times 2, 92 degrees. Is that okay? Okay, last part. We're going to classify the triangle by its angle and by its side. So, on this picture here, I guess I need to figure out what the measurement of angle H is in order to determine, what the side or what the angles are. So how would I find the measurement of H? Good. So she said I can take 54 and 36 and add them together, and then subtract them from 180. So 54 and 36. And subtract 90 from x. So that means that that angle is a right angle. All right, so if that's a right angle, how would I name it by its angles? What kind of triangle would it be? Hey, it's a right triangle. But if you didn't add that up, you might not have known that it was a right triangle. You might have just thought it was an acute. All right, if I'm going to name it by its sides, okay, what would you think? Is there anything that tells me that the sides are equal? No. All right, as long as these angles, 54 and 36, since they're not equal, that means that there's no sides equal either. So it has to be what kind of triangle? Scaling. So it's a right scaling triangle. None of the sides are equal. All right, so how would you find the measure of this exterior angle? How would you set it up? Heard it? X what? Plus 70 what? Very good. All right. The two interior angles equals the other exterior angle. You move your x's to the same side, giving you 70 equals 2x plus 10. Subtract 10 from both sides. 60 equals 2x. And divide by 2. So x is 30, but it's not what it asks for, is it? It wants the exterior angle. So that means that we have 3 times 30 plus 10. All right, 3 times 30 is 90, plus 10, you said it's 100. So 100 degrees is your answer.